Start recording. Hello everyone and welcome to Handmade Hero, the show where we code a complete game live on stream. We are here on day 331 and we were just finishing up some bugs stuff yesterday. I think there's a couple little remaining issues to check out. I think we missed one. Kim reopened this one because he said we also need to do the float one. So we should probably do that. But otherwise, I think we got most of these down. I haven't heard from anyone yet on this guy right here. Like I said, these are just, someone needs to figure out the macro thing. So I'm going to leave this one around. We're not going to address it because I think that's the last thing. We're not going to address that until someone tells me what we might need to do to fix the macros completely, like gives us a working example. Because until then, I really can't play with it much. I'd have to install Clang to like start testing it or something like that. And I don't really think that's a useful thing to do at this point. So if someone who really cares about building under Clang wants to do that, go ahead and do that and let me know. And if you know, if I get that, I'll definitely do it in short order. This one, however, we can do. This was just a case of I forgot one of them when I was cleaning this out. And like I said, day 331. So this is day 330 source code that I'm editing here. Let's go ahead and get that going. So here in the printf, what we were doing before is, again, and I'll just say this one more time, but I think it was probably clear for most people. When we're reading var args off of the stack, C, for whatever reason, and I'll be honest, I don't really know the reason historically, but the way that it puts things on the stack in a var args function is it will always expand them to be certain types. So if you try to put an integer on the stack in a var args function, it will go on as an integer. But if you try to put a char, like an 8-bit value on the stack, it will actually expand it to 32 bits first. That's just how var args works. And I'm assuming this had something to do with stack alignment or something. I really don't know, or maybe convenience. I'm not sure. But for whatever reason, that's how var args works. So it is not the case that when you put a char on, you get a char off. You put a char on, you get an int off. You put a short on, you get an int off. You put an int on, you get an int off. You put a float on, you get a double off. You put a double on, you get a double off, right? And I missed one of those cases when we were doing that here. Really, this one length equals 8. Really what happens in this function is it's always this case. I believe it's always going to be a double. I don't think there's any way to actually push a float. I'm not sure about that, but I think that's the case. And so that was the bug Clang was complaining about here, with the float part still needing, you know, it's basically saying, hey, you know, that float will get turned into a double, so when you pull off a float, you're probably doing something wrong. And like I said, I think that is exactly what the spec does, so that was just, that's Clang catching a potential error that we just don't have right now. But it's accurate. So let's go ahead and take a look and make sure that we're still working properly here with that change. And it does look like everything's fine there. All good. So yeah. Hopefully now we can actually mark this. Okay. Hopefully I actually fixed it this time for you on day 331. Here we go. All right, so now I think we are down to not having any particular bugs here that I'm going to address in short order. Again, this guy is mostly done on the other parts, so this part I think is all done, but this part here is not. And so if somebody does want to take the initiative who has Clang and works with Clang to figure out how to make our debug macros work okay with it, I will make that change. So just let me know about that. And I don't know if this is that, if this solution works okay, we could switch to it potentially. But anyway, someone needs to figure out, like, and send me, hey, here's the defines that allow it to work on Clang. These are what you should use. We will switch to those so that people compiling with Clang will not have to worry about that anymore. Because in theory, we are now compatible with Clang everywhere else because we fixed the other issues, if that makes sense. All right. So that's it for that. I'm going to leave that open in case we need it tomorrow or the next day or the next day or the next day. And I'm going to go over to our to-do list, and since we're kind of coming back from a long break, I just want to kind of figure out, maybe what we should be doing here, because we need sort of a plan of how we want to tie everything up. I'm pretty certain that really mostly all we have to do is that Z fixes, and then a couple things with the renderer maybe just to make sure that we're clean enough that we don't spill over any problems with our renderer that still exist aren't going to cause problems in the game code. Because we can always upgrade our renderer later, right? We can always make our renderer better at any time, and it's zero cost to us. It'll just improve the look of the game or whatever. Like if we add lighting, it'll just magically look better, right? But if we have some kind of an architectural flaw with the way that stuff is fed to the renderer, which we might have, right? In that case, then we run into a problem because then all of our game code is written to that rendering API, and now we need to change it. We now have to go touch all of our game code and sort of spend a lot of work, making that happen. So, I don't want to leave us in a situation where I suspect we might have some problems with the way we're feeding the renderer. So we may want to take a little bit of a look at that as well. But like I said, we don't have to worry too much if there's anything that we need additionally from the renderer going forwards. That's actually okay because we don't have to get everything right at the outset. We just want to make sure that we aren't having too much sort of leakage of bad decisions in there, because if we ever want to upgrade the renderer, we don't want to have to rewrite all of our code that talks to it, right? And maybe that's not such a huge deal in this case, in this particular game, because we do have a pretty narrow, like everything is an entity, and the path that renders things is pretty narrow. Like it's kind of just at the end of the entity stuff. And so, maybe in this case, we don't really have to care. And it won't be a big deal, so it might not be a thing we have to care that much about, but we'd at least want to just look at it and make sure that everything's fine. So let's take a look here at what we've got, right? Here's our to-do list of things that we need to know, and I think at the moment, if we were to look at the stuff on here, I feel like this debug code stuff is probably at the point where we could, we could probably sort of do some of these guys. There's not a whole lot there. We have the frame view not showing bad frames. That's a thing that we want to kind of fix. And we have that problem that we're still running everything through the fairly complicated graph sort, even though we don't really need that for debug stuff because it's a fairly straightforward sort. So that's something that we might want to, fix as well. On the entity system side of things, we've got this to do here, which is what to do about geographically disparate entities that might only partially get streamed into a sim region, but which need to move together as a unit. You can see why that's a problem. Essentially what's going on there is, let's say we have that, that snake creature, right? And you can see, we made one of these guys, right? He's hopping around there. That snake guy, he's 5 segments long. And if you think about what's going on there with that snake dude, he gets streamed in as 5 separate entities, which is good. That's sort of what we wanted him to be. But what that means is that in the case where just like part of the tail or something was in a region that didn't get streamed in, right? So he gets streamed in, most of him gets streamed in, but part of him doesn't. That creates kind of a nasty situation potentially. And so there was a question of whether or not we wanted to try and do something with the entity system to prevent that sort of thing from happening. Meaning to prevent the case where we sort of have entities which, are left in that sort of limbo, right, where they could get split. And, you know, one thing that I think would be interesting to do there, because I think we actually maybe have some options that don't involve anything particularly complicated, because we can pretty easily bound the size of these guys. You know, we can say that there can't be something that's like 30 long, probably, right? I don't know, maybe we don't want to say that, but you can kind of imagine what the problem is here with these sorts of things, where, you know, if we stream part of it in and not the other part of it in, we could imagine solving that by just saying, okay, instead of streaming in just the stuff that we're going to consider active, we could stream in, again, like use that sort of apron concept, stream in a little bit past that. But don't consider any entities in the region that's, don't consider entities in the apron to be actually active, right? And then what we could do is just make it so that if an entity is part of a brain that is active, but it's in the inactive region, then it becomes active, right? So we could make a way essentially to enforce, or not really enforce, but make it so that you'd never get entities that would get split up like that because of the placement of the streaming region. I think we could do something like that. I just don't know whether that creates more problems than it solves, or whether it's really worth even caring about or worrying about. I really don't know. I have no idea. And if you assume that things are generally confined to rooms, then for the most part, this would only happen when something was crossing a room boundary, right? It would only happen when, like, one of these guys is, like, going out a door, like, out one door and into another room, where it can even get messed up in that way to begin with. And so, again, I really just don't know about that, but you can understand what my concern is with it, right? Hopefully. All right. So I don't know. I really just don't know what to do about that. I'm not sure. I don't have a solid idea for it. What it would look like is in here, you know, when we do this thing, this would all be exactly the same, right? So we'd have this loop would be exactly the same. Maybe we expand this a little. Maybe we don't. I'm not sure. But what we would do here is say, okay, when these things stream in, we would have a notion per entity, right? So in the actual entity that gets streamed in here, you know, we already have flags, and what we would have is a flag that said whether or not this was actually active, right? So we'd have an entity flag active, and by default, anything that was inside the region that we are going to animate is considered active, and anything outside that region is considered inactive and would not get animated. And then what we would do is when we look at a particular brain, right before we start actually processing the scene, we loop through all the people in that brain, and if any of them are active, we mark all of them as active. So it will suck in people from the apron region and make them active. Again, I don't really know if this is a good idea or not, but hey, it seems like something worth trying, so I'm going to go ahead and try it, right? Because why not? So let's say we add an entity flag here called active, right? And inside the code, when we're going through these chunks, all I would really need to know is sort of that, again, that updatable bound and the update safety margin kind of thing, right? We sort of already had this concept, I think, to a certain extent. In fact, weren't we already, you know, we had this thing for updatable bounds, right? We had updatable bounds, which were not the same as bounds. And I don't really know. Oh, so we actually have an updatable. We already have this concept. I don't know why it's not a flag. I don't know why it's that way, right? That's a very good question. Like, why that isn't a flag, I do not know. I'm gonna try changing that. So I'm going to say, okay, if entity overlaps rectangle in the updatable bounds, I'm going to say desc flags or equals this flag that says whether the thing is active or not. Where did that go? There it is. Flag active. Here we are. And then I'm going to take a look at this stuff here. Okay, so we were using that inside update and render entities. So I guess we're already doing what we need to do here. So we've actually already written this because of the collision stuff, the way we were doing it. So that's kind of nice. It means I don't really have to worry about implementing that newly, right? And off we go. So we already have it so that nothing happens if this thing isn't in entity flag active, so that's great. So now all we really have to do is inside Handmade Brain, well, I guess it's not really inside Handmade Brain, but we want a sort of pre-pass on the brain execution stuff where when we go through these brains, the first thing we do is mark anyone who is part of an active brain as being active themselves, right? So I believe in world mode, here we are in execute brains. So what I might do is like, okay, let's do a pre-pass after this. I'm sorry, before this. Let's do a little pre-pass where we do like mark brain active, or something like that. Mark brain actives. Something like this. And that's just going to be a thing which goes through all of the entities that are in the brain and does that marking. Okay. So the way this would work, I think we would want it to be sort of like the snake, right? You can kind of see here. I'm assuming we've got a segment count on these brains. Not a segment count, sorry, a member count, but let me make sure that's true. So we have a brain type, is type, where is brain? Brain, there is brain. So there's our entity array, and so we can just step through this entity array for however many that there are, and I believe the maximum number that there are should be known to us, right? I feel like, let's see. I guess we don't really know how many there actually are, do we? Which is kind of unfortunate, because we want to sort of loop through those and check. Well, we must know, because we can at least assert that we're not writing out of bounds. So let's go ahead and check. Inside sim region. Here we go. So here is our sort of hacky code for doing it. You can see that we had trouble with it. In fact, I remember this discussion where I was like, I really wish this worked better, right? In languages like C, like I just want to say, hey, however many the most number of entities there are, that's how many I want to be treating in here. But yeah, so I guess the answer is this sort of situation is unfortunately all we can really do. So let's maybe at least systemize that a little bit. Let's go ahead and try to make that something that's not so specific to that circumstance. Something where we can ask how many of these there actually are, you know. So what I'm going to do here is I'm going to say, let's make a little inline or even a pound define, let's say. Which is like brain max, entity count or something like that. I kind of want to be in the other window here. So I want to compute, for brain max entity count, I want to compute how many of this array there actually could be, right? And so you can see how I was doing that here. I took essentially this sort of rather odd way of doing things, but it's the only way I could really figure out how. If I was to take a brain and go forward the size of the brain, and then go back one entity pointer, right? That was going to be the maximum one that there was, right? That was going to be the furthest out that there was. So really, I could just not do that, right? And say, well, there's size of brain, and size of brain is the whole structure size, right? And then what I could do is just say, well, I know that the array starts here, right? I know that that array starts here. And, you know, I'll be honest, it's a little bit weird that it's, oh, no, that's correct, right? That single pointer. So I know that it starts here. So if I subtract the offset of that thing, and I don't know if I assume we did offset of at some point. Maybe not. Offset of? No, I guess we didn't. Did we really not have one of those? Offset from struct? Huh. Well, I basically want one of these. So we might be able to just use this one. I don't know if it's baked into this in anymore or not, or if it's something that I have to include this for. I think I may have to do a pound include for it, in which case I'll just do it myself so I don't have to use the pound include. But basically what I want is just the offset of a member in a struct, right? So all I really want to do is say, hey, the offset of this member inside the brain, I want to take that and I want to subtract that away because I don't want to count these guys. So I just want to see how big the brain is in that sense, right? So once I have that, I know the total size of this union part. And since I know that it's all entity stars, all I have to do to figure out how many of them there are is divide by that length, right? So that should give me the maximum entity count of one of these things. Now, if I then go here, and I think, like I said, I'm going to have to write that offset of myself, I would suspect, but who knows, we'll find out. So if I was going to do that, what I could now, once I have that, I can then go ahead and say, all right, there's an entity index. It goes from 0 to the maximum number of entities that there can be in the brain. And let me go ahead and give myself a brain here to work with. And then so inside that brain, I'm going to do 2 loops through. The first loop through, I'm going to say that whatever the entity star, I'm not sure exactly how to access this here. I guess I would just say, yeah, I guess I would just say get slot. Do we have one of these? Yeah, here it is. Oh, in fact, there is the code for the offset of, right? So we actually did the offset of stuff, but we just didn't do it. We just didn't do it as a macro. We just did it directly, which is fine. Anyway, so in brain slot 4, let's see here. We're calling this guy with the pack value, which is the distance off. So basically we're figuring out what the index is there. And how do we actually get that brain slot back? I guess we haven't had to do that. We haven't had to iterate through these at all, it looks like, right? But what I want here is I essentially want to do like get, you know, entity equals get entity in slot. And I want to pass the brain, and I want to pass, I guess this is technically the slot index. Right? So I want to be able to get, you know, the entity in the slot, and then I want to say, I want to have a B32 here, which is like is active equals false. And then in here I want to say like, oh, okay, if entity flags and entity flag active, then I'm going to do if active equals true. Right? And there's another thing I could do here, which I might just do just in case for future proofness, because it's actually pretty easy. Maybe I'll do like combine flags or brain flags. And then what I could do is just say, okay, for each of these guys, like brain flags or equals entity flags. So this will just accumulate all the flags. Then at the end, I just say, all right, if brain flags and entity flag active, that means somebody, at least one person, had to have been active in order for that flag to get set. So then I would come back through here and say, all right, now take the entity flags and or in entity flag active, right? Because now everybody in this brain, it gets magically pulled into the active region, right? Hopefully that makes some sense. But we need to have some way of doing that get entity in slot, because we don't have that right now. And so that's going to be something we have to go implement. Now, in this case, here we don't have to do anything. Let me go back into the brain and do that max entity count thing. So here is max brain slot count. And yeah, that I believe is going to be correct. Again, this offset of, I'm going to go ahead and define my own offset of for now, because we're using it in two places already. Here's the type, here's the member, right? And it's really just this. So the address of this guy is I think all we really need for the offset of. I think that should do it. And let me see if that works. Let me just convert that. So now all we really need to do here, and I'm going to put that in a useful place as well. I'm going to put that in here because this is something I would generally want. I don't know why we didn't have it, but we didn't. So now we do. And get entity in slot, we need here in the brain. So in order to get an entity from a slot, we need something that looks like this. Where we pass the brain, and we pass the slot index we're going to use, right? And then what we need to do is say, okay, we know we've got an entity star. We should probably do an assertion here that the slot index is less than the max brain slot count, because you can't fetch one past that, right? But then we know the result is going to be whatever the array pointer is here, right? We should be able to get a pointer to that pointer, right? So now we're pointing at this guy. Then we just want to go forward however many slots we're talking about here. And since this is a pointer to a pointer, we could just say access this is like an array and give us out the actual pointer at the slot index, right? Then we return the result, and now we've gotten back that guy. So we're just using this as a marker to allow us to index into all of these guys who happen to be in the union, and go from there. Okay? Now, in theory... Oh. Duh. We've got one more thing to do. When we get this entity out, we don't know if there's actually an entity there. Right? Those slots could be empty. So we definitely have to check to see whether they're null, because we only want to edit if they're not. All right. So now we would need to actually do some testing on this or something. We're not at the point yet where any of that makes sense. But we don't really know if this worked at all. We're strictly putting it in there as a way to mitigate this problem so that now it's in there architecturally, so we're aware of it as we move forwards, meaning we know we have to kind of maintain that concept and keep it going. All right. So in theory, that's okay. I don't really know. There's issues with that. Obviously, one of the issues is that if those things are pulled into the brain, well, the whole point of that apron where things weren't active is that we don't know if they can move to certain squares because those squares might not be there or might not have their blockers in them. What I will say is I think some of that has been mitigated now. The reason some of that has been mitigated is now that you move to specific squares, if a square hasn't been streamed in, you can't move to it anyway. So at that point, you're not going to do something like move to somewhere that you couldn't have moved because it wouldn't have been there, right? So I think that's probably okay. I'm at least a little happier about it, so that's all right. Okay. So let's talk about some other parts of this here. What do we want to do here? I don't know that I'm in the mood to do anything with the debug code at the moment. I'm going to demote that to some time when we feel more interested in it. It's just not really my jam at the moment. And yeah, fix clicking bug at end of samples. Again, these are things that I'm not sure we really need to be doing at the moment. And maybe we do these at some point when we're feeling in the mood to do some cleanup, some code cleanup. We can look at them because they're not really architectural. Like the clicking at the end of samples is a totally random bug that we can just fix at any time. It doesn't affect anything else in the program at all. It's really just not important. So yeah. So I think mostly I'm going to move some of these up here. I don't know. Multiple sim regions per frame and per entity clocking. That is definitely a different thing. And so is AI pathfinding, right? AI pathfinding is definitely something that we don't really know how we would do at the moment. I mean, we know we know what we would probably do for pathfinding on a single screen, but we don't have a lot of ideas about how we would do pathfinding more in the large. What I'm assuming is I think probably what we would do is maintain a single pathfinding grid of some kind, a single pathfinding network for larger scale pathfinding that people just use. And so I don't think we will do large-scale searches for individual entities. I don't think that would be necessary. I think we could just use the same search grid in those cases. So I think we can probably just run those path finds as they need to be run. So I guess I'm not too worried about that. AI storage, I think, will just be stored in the entities. So I think I'm actually not particularly concerned about this. So I think this is not... I think the brains are what I wanted. And I don't know that I need any of this stuff. I don't think there's really anything in particular going on there. It does, however, I think when we do world generation, where is that? Rudimentary world gen. I'm going to put that in here. Because when we generate the world, I think that's the part where we would probably need some of that pathfinding to occur, right? So entities could kind of find their way around. So when we generate it, we're going to want to keep like a connectivity thing, I think. You know, we're going to need something where we can kind of go, okay, you know, this is how we created the world, so we have like its backbone, and we could do pathfinding on the backbone. And if there's things like doors or stuff, they're kind of semantically in there or whatever. We're going to need something like that, because there's no way to do large-scale pathfinding, I don't think, for the sizes that we kind of allow the world to be. Like, we don't really have any practical limits, for the most part, on how big worlds can be in Handmade Hero. And so I don't really want to worry about if someone wants to make a really giant world in Handmade Hero. I don't want them to have to do, like, I don't want the pathfinding to actually be trying to deal with that, because it would just roll over and die. So I think it needs to have kind of more of an understanding of what's going on there at a couple of levels of detail. All right, so let's see. For architecture exploration here, I'm going to kind of start working on this to-do list a little bit more seriously. So I think Z is probably the most logical thing to do. probably next. That was sort of what we had worked on a bunch, and we haven't quite still finished it. So I think maybe that's what we should be working on next. Rendering-wise, I feel like the 18,000 draw rectangle calls, we knew what that was. That was all of our fonts, right? Happening there, I believe. So some of these things have kind of been done, and some of them haven't been. Final optimization, I think we can... well, and hardware rendering we sort of did. We actually did do render to texture, so that's actually done. And for shaders, I guess I don't know that we want to do those yet. We could do them. We could do them, I'm not sure. I think these are things I'm going to just kind of postpone because I don't really care about them very much. They're really not particularly important. But we would need it if we wanted to do lighting, right? If we wanted to do lighting, there's probably no way to implement lighting in the fixed function pipeline in OpenGL. So we would have to use shaders in order to do that. There's really nothing else we could probably do about that. So there's that, I guess is what I would say. So we will need that if we decide to do lighting. So I've got to think about what I want to do there. Those would probably be done together, would be my guess. For the coordinate systems, we're pretty close on that. That's here, basically. So I think this pass includes straighten out all coordinate systems because it's the final pass on that stuff to make sure that that's actually good because there's still a little bit of jankiness in the Z. I don't know that we have a problem still with projections. I feel like our project and unproject now work properly. So, I mean, in some sense, we don't really have real projections, like we're not doing a full projection matrix or anything like this. But on the other hand, it seems like it's fairly solid at this point. Like, for example, we do back project the mouse properly now and all that sort of stuff. So it seems like that's working okay, at least at the moment. So I'm going to call that something that if we want to investigate more later, we certainly can if something comes up, but I don't think there's anything much to do there. Final optimization here is something that didn't really need to happen. So this is like more like extra credit. This is like final serious optimization of the software renderer. Because we never really did that. I showed some basic optimization of the software renderer, but we never really tried to get down to the really nitty-gritty of it and make it run really fast. We did basically a cursory kind of like obvious pass on it, and that was all we did. So, you know, at some point, if we decide maybe after the game is entirely done, you know, and our hardware renderer will be totally fine because we're just not stressing out hardware very much with this game, you know, maybe we want to go back and make it totally playable in software, you know, 30 frames a second and all that. We could go back and do that. So, but I'm going to put that down there because we don't really need to do that at the moment for the game because we ended up doing the hardware renderer. So we now have a way to run quickly without the software renderer. We don't have to worry if the software renderer is too slow to deal with, you know, various stuff. But that doesn't mean it wouldn't be fun to go do that optimization someday. So I'm going to leave it on there. For rendering left over here, we've got particle systems and lighting are the two big things that I feel like we are going to need that we don't have at the moment. Lighting is, you know, one of those things where it's like unclear exactly what that entails because it's a lot of, you know, lighting is always kind of a hacky approximation thing. Even when you do 3D, it's hacky. It's not just hacky in 2D, it's hacky everywhere. So I don't know exactly what we want to do for that. We played around with it a little bit back in the day. But we never really settled on anything because we kind of needed to get like our layers working properly. And so we're finally kind of converging on having that. But that kind of had to do with the lighting. What I would say about lighting is it does feel like something that would be better to work out sooner rather than later. So I think I want to kind of leave it on this list. And what I might say is, well, particle systems are probably easier and probably do impact how we send things to the renderer. So I might say let's do a particle system pass after the Z, and then we'll do the lighting pass. I don't care about the 18,000 draw rectangles call thing. That's not a huge deal, I don't think. But what I do want to do is there is one thing on the debug code. I want to disable sorting. Because that was really too much for it. So I think we know all this stuff. So I think most of this stuff is actually fairly set. Concept of ground collision. So we fixed all this because we use sort of that moving from fixed position to fixed position. So I think we just need to kind of go through and do the straightening up of our z-pass. We do need to make sure that this sort of thing works for our collision where you can have flying things going over low walls or what have you. But we need to kind of definitely need to make that happen. Now, here's what I'd say about this. I feel like what we want to do is, at some point in here, we want to schedule a switch over to new artwork. Because a lot of our artwork is broken right now. Like, if you take a look at, because the way that I had just put in our test assets, I don't know if we still have the sort groups. Yeah, we do. So if you take a look at these sort groups here, it's just absurd, like how big they are, because they include all of this empty space around the hero, and they're aligned wrong and all this other stuff. Like you can see, that's the box, the actual rendered area of this head here. And that's just stupid. It's just wasting a lot of real estate, and it makes it really much harder on the sort as well, because now there's tons of things that say they're overlapping and they're not really overlapping, you know? So I feel like we want to move over to cleaner art sometime soon. And I feel like maybe here would be the place to do it. So I think we want to do like transition to new artwork. And I'm going to actually put real artwork here, I suppose. Because Anna has a whole set of art for us now that she did that includes like multiple heroes and enemies and terrain and like all kinds of stuff that she did in a couple weeks that is really good, and it's the right perspective and all that stuff too. So I feel like we want to transition to that probably after we do the particle system stuff, because before we start trying to work on lighting, I feel like lighting is going to be something that wants to have the correct artwork in there. And I also feel like, yeah, like it'll help with the rest of the stuff. Okay. So for collision detection, we definitely need to do that. I don't know, for animation, I don't think we actually need any more than sort of what we have at the moment. I was pretty happy with the hopping hero. And so pretty much that, I think that's mostly it. We could clean up the way that code works a little bit once we kind of transition to the new artwork. So I might just go ahead and say here, just a real artwork, I might say clean up our notion of multi-part entities and how they are animated as a part of that transition. Because we probably don't need to do much more than what we already have, but I feel like there was some jankiness in how those things worked, and we kind of introduced them in an ad hoc fashion, so maybe go through there and just clean it up a little bit, so it's a little bit more like how you would do a normal traditional animation system, so we don't have to worry about it too much. So that's good. Multiple sim regions per frame with the per entity clocking stuff. That's harder because I don't really know how we're going to figure out where we do these sim regions. Just to give you an example of what that is, So multiple sim regions. The idea here is there's a couple of different things we can do in the game. But what we allowed is, if you actually look at how we wrote the code, you can actually make it so that, the size of the world might be massive. So maybe like this is like how big the starting area is, and maybe the game like actually gets out, like maybe that, like you can't even see how big a screen is. Maybe the game actually ends up being like so huge that it would take you like, 30 minutes to walk from here to here if you just went a straight shot or something. So it's really large. So one of the things that I wanted to support in the game, and I don't really know exactly what we would use this for, but I kind of think it might be nice, is I think it would be cool if there were some autonomous agents doing things in the world while you were elsewhere. So a very simple example would be, let's say that maybe there's, something random, like there's a dragon here, and the dragon like flies from here to here, right? That's just something it's going to do. And if you happen to be here when it's passing by, you'd see it fly overhead, right? So in order to do stuff like that, we need a way of updating parts of the world that you are not involved in, right? That are not where you are. And so what I was thinking is we could maybe keep a list of active entities. So maybe like, there's a list of active entities. And, we somehow update parts of the world where those active entities are, So if there's an active entity in a particular region, we would run a time step on that region, as if it were a player, And so the only problem with this that I foresee, because that's not very difficult to do, right? If you think about what happens right now, we call that begin sim, end sim thing. Well, it'd be free for us to just call that more than once. And furthermore, I believe that thing is almost entirely thread safe. It's really just the pull out and the push out, the pull out of the world and push into the world thing that's not thread safe. Because once it pulls it out, it operates entirely within its own structured set, and it doesn't ever talk to anybody or do anything else. It's like kind of all self-contained. So it's actually pretty easy for us to run this across multiple cores as well. We could run 4 updates at once, for example, 1 on each core, and not have any problem with that. But what I don't know how to do is deal with the part where they coincide, right? So let me just show you kind of the basic idea there. So let's say that I have, here's the dragon, and here's the hero, and here's their update regions. So here's what's being simmed. If the dragon is coming this way and the hero is coming that way, eventually their regions will overlap, right? So eventually we'll get a case that looks like this. Here's the hero's region, here's the dragon's region, and there's an area that's in common. So what will happen there is whoever packs out first will grab this stuff into their sim region, and the other person just simply won't get it. And that's not really going to work, right? That's going to create all kinds of bugs for us. So what we would need to do in that case is we would need to not update like the dragon's region or something. Now that's not that hard. We can pre-check to make sure that regions don't intersect with each other. And if 2 regions do intersect with each other, we could update only one or the other, right? And that wouldn't be too bad in the case of NPC regions. But in the case of the hero region, we know we have to update the hero region every frame. So I don't know what we do with the dragon region at that point. Does the dragon just stop moving until you actually scroll over him? It just seems kind of busted. So I really don't know what to do, And we can't call them sequentially, because if we call them sequentially, then the things in this region will update twice. Right? They'll get essentially 2 time steps. And we don't want them to have 2 time steps. Now, what I suggested kind of over on the to-do list is the concept of per entity clocking. So the idea there is that every entity has a clock in it, and when the update region passes over one of those entities, if that update clock, depending on how we record it, can somehow indicate that it's already been updated this frame, then it doesn't move on this frame, but it is still there in terms of for collision purposes and whatever. I don't know if that would work. I really don't. It would certainly cause problems with the brain, because what if you have some that have, you can't partially update the region like that. So this is like a really concerning thing for me. I really don't know what to do about it. Here's another thought, and it's basically saying, well, if we have performance to spare, which maybe we will, if we have performance to spare, there is another thing that we could do, right? And maybe this is the right solution because I can't think of any other solution that actually works. Maybe what we do is we just merge the regions, right? So maybe if there's the dragon and the hero, what we do is we just merge these two into a single sim region. Because remember, our sim regions don't have to be rectangular. We could pull from 2 different rectangular regions into the same sim region and create a sort of other, a non-rectangular convex shape. We could certainly do that. The only reason I'm worried about that is that makes the cost of simulating that sim region go up, right? And if you got into a really bad scenario, like let's just imagine the worst possible case, right? The worst possible case is this. Right? Like the hero is here, the dragon is here, the basilisk is here, the hydra is here, right? The manticore is here, right? I don't know, this is Bob. Right? In that circumstance, now we have, what is essentially, especially if this region is small, so the overlap is not much, it's just enough to cause them to merge, but it's not very much. Then, however many of these we've got, that's like 6x the cost of simulating that region, right? And so if previously the way we were handling this load was by, not doing everyone every frame, or also using the multi-threading. Well, we can't use different sim regions. We can't assign different sim regions to different threads if they're all in one region. We could try to multi-thread our single region update, right? And then it wouldn't matter. But assuming that we're still trying to do it regionally like that, that's not going to work. And so we don't get the multi-threading benefit, and we don't get the benefit of being able to time slice these guys anymore, because obviously the whole region has to update at once. So that's what I'm really worried about. Otherwise, merge would definitely be the way to go, right? And I'm not sure what to do about that. Because it seems like anything that I might do, like, oh, okay, well, just pretend the dragon's region is smaller in this case. Well, okay, so pretend they overlap more or whatever, right? So I feel like what happens is when these things converge, we just end up in a situation where we can no longer use any of the tricks that I think we would be able to use to keep everything running like reasonably, even if we throw like a lot of these creatures at it, Even if there was like 300 of these or something, right? 300 actors all doing stuff throughout the world. Well, that's really not that big of a deal because, first of all, we could say, let's update everyone only like every 10 frames or something. Right. So now you only have 30 that need to update on any given frame, right? That right there made it much more manageable. Now let's say we've got 4 cores, right? Okay, now we essentially only have 8 updates right? Because each core only has to do 8. That chunks down pretty nicely, right? And it starts looking a lot more manageable, a lot more feasible once it looks like that. But if they all merge together, all of a sudden it's all 300, and it's just, I think it would just be an epic disaster. Epic disaster. So that's the main problem that's stopping us from doing that, and I don't really know. It's time for the Q&A, so we can go to the Q&A. But I guess I would say that's really, I just don't have a good idea really of what the right way to approach that problem is. JFE, what are the reasons for separate regions again? The reason is because you can't simulate a world with, millions of entities every frame because it's just too much computation, right? So what we want to do is just let most of the world sleep, and we only load them up when if it's actually a somewhat autonomous region or we think there's something happening there. Right. And the other thing that we use the regions for is to put everyone into a single uniform space so that we can do our computations there, because we don't actually have limitations on really how big the world could be for the most part. In fact, now I think we could almost get rid of even the tile concept, so they could be like literally as large as you want. We could actually start doing some crazy stuff with that if we wanted to. But anyway, that's neither here nor there. The point is simply that we use those sim regions to bring everything into a single floating point space where there's plenty of precision. Is Bob the guy in the tree? Yes. Let's say yes. Related to J5's question, so I was playing Kingdom New Lands recently, and it seemed like there was some really bad frame rates that coincided with battles involving hundreds of entities on the opposite side of the world. Like opposite to where the camera was. Yeah. Well, yeah, I mean, one of the problems with this sort of thing is just that it's an architectural issue, right? That's exactly what it is. It's one of those things where we don't have to solve it if we don't want to, because you can make a perfectly reasonable 2D game that doesn't care about any of this stuff. But I am trying to kind of show some more advanced things that you might need to consider architecturally, and so like you point out, in other sorts of games like Kingdom New Lands or who knows what, you could definitely get into situations where you want this sort of expansive world simulation thing going on. And if you don't have some way of degrading that simulation when it is not absolutely crucial that it's running at 30 frames a second or 60 frames a second, you're going to run into problems because, once you scale the world up to a certain size, it's just going to fall over. So we're trying to sort of have our architecture at its fundamental level have certain ways of dealing with that. Are they necessarily the best ways of doing that? I don't know. We just picked some that seemed reasonable and which solved problems okay, and we got there, And it seems like our architecture at the moment actually does a pretty good job of allowing us to multi-thread and sort of time slice updates to parts of our world if we wanted to, for almost for free. And the only place that it really breaks down is that part exactly where the regions would merge together. Now, what you sort of said there, where or sorry, not what you said. What Insofar as says, have you considered only merging with the heroes region and deactivating ones past that, or having the regions aligned to a grid room so that they don't overlap? So I'm not sure. So considered merging with only with the heroes region and deactivating ones past that. The problem is you can't deactivate them because they still need to update, right? Is one of the problems. They need to update eventually, otherwise the basilisk would just stop moving, right? In this case, if all I did was allow like these to merge, well, the basilisk and the manticore would now be frozen in their tracks, which doesn't seem like a good solution. It would create some potential gameplay bugs there, right? Now we could do it if it's the only thing we could think of, then we could do it, right? Because hey, creating a gameplay bug, sometimes you just have to make things work, right? Depending on what your goals are. So if they're little gameplay bugs, okay, it's all right. And speedrunners will take advantage of that, and hey, that's great, right? If you've ever watched the Super Mario 64 video where they use essentially exactly that, the deactivation regions, to do kind of crazy speed runs of things, or half A button press runs, gameplay bugs aren't always bad. Right? Gameplay bugs can be very interesting. So I'm not even saying that we couldn't do something like that. I'm just saying when I think through these problems, I try to come up with a solution that actually works everywhere if I can. And if I can't, we'll relax it, right? So that's the reason I don't think deactivation really works. Your other suggestion of having them be aligned to a grid so they don't overlap, the problem with that is I'm not exactly sure how to do it. Right now we have this concept of the active region and sort of the apron. And like I said, we have this problem where that apron would need to overlap for these two regions, right? Because even if we ensure that that the active regions don't overlap, which we could do, the aprons of them would still overlap. And there's no way to ensure the aprons don't overlap without basically saying that the dragon can't get within a certain distance of the hero, right? Which is the opposite of what we want. So the aprons are the problem in this case. And even if they weren't, I think the active regions would be a problem, because the active region, we said, was one room's worth to on all sides, right? And so if that's the case, if you're in this room and the dragon is in this room, right, then we sort of have that problem of, well, we kind of need to merge these, because they overlap. So I don't know. Maybe it's okay because, hey, in that case, you could just say, well, the dragon doesn't simulate the room below him. His region shrinks down to just one room. And then if you're more than one room away, you don't have this problem. But then again, you still end up in the exact same problem, I think. Maybe what we could do is say that there is no room border on the other guy's sims. Maybe there's no room border for the other people. Q colon. Terror Scout says, could you have smaller regions and load 9 active at a time, so you always have every boundary region loaded all the time? I don't think I understand what you're suggesting. So I am not prepared to say why we would or wouldn't do that. Could you have smaller regions and load 9 active at a time so you always have every boundary region loaded all the time? Yeah, I'm sorry, I'm not sure I understand. So, yeah. But I guess here's the thing. It does seem possible that if we said that updates were always grid aligned, so they're like they're room aligned, and if two regions would merge, then those regions, the region that's not the heroes region, doesn't include that boundary piece. See, I don't think that works either, because here's the thing. So let's say here's a room, and I'm simulating this room. In order for me to walk out this door, I need to know that there's a tile on the other side that I can hop onto, right? So at least part of this room has to be loaded. Otherwise, I can never actually get there, you know? So I think you're always going to have this problem. Cyberpunk Hobo, couldn't you just make sure regions that get pulled in by the apron don't have their own apron activated? I don't think that really helps the problem, though, because the problem is regions that are active, right? The problem is when the active regions, the active apron, the aprons of active regions overlap. Or even when the active regions themselves overlap, but, you know, the grid alignment would presumably help that problem. But assuming that we didn't, you know, then it's like that apron is going to overlap. And if the apron overlaps, I guess since it's not marked active at that point, that's okay. You couldn't run it multi-threaded. You'd have to have a different solution for the multi-threading. So here's the thing. I suppose we could still do time slicing. And potentially get us out of this problem. So maybe what we could do is say, all right, we will merge the heroes region, but we'll only merge it with one of the neighbors. So if two people overlap, we don't merge those. And we don't merge with another person who's on the outside, right? We could do something like that. Now we still have we still have the problem of the clocking, because people in this region, right, are then going to get updated again on the next frame by one of these guys when this is dormant. And so this will have updated twice, whereas people in here and here will only have updated once. And I don't really know what to do about that. And JFE, The actual problem when two regions overlap is really just the expense, right? It's that if you get enough overlapping regions, I think it's just going to cost too much CPU to simulate it, right? That's the only problem. If that weren't the problem, then I think you just always merge. You know? You just always merge. And maybe we just let it slow down. It's like, hey, guess what? If you get into that situation, sucks to be you, man. Sorry, Mr. Player, your frame rate tanked. Buy a faster machine, right? Because we could totally do that. And then the solution is just when things are next to each other, they do merge. And you merge till you have a single connected region, and you run that region, right? Mr. Froch mentioned you could always artificially keep the non-player agents away from each other. It's true, I could sort of have some sort of avoidance there that makes it unlikely for this to happen. And, you know, maybe that's the best solution if there isn't a good tech solution for it, you know? The Sizik, what do you think about a Boolean flag on each updatable thing? Flip it when you update and alternate each frame, which value you check for. Yeah, that's what per entity clocking was. Some, you know, because you could imagine a couple different schemes. One way I was thinking is just in the entity there's a what was the last tick it was updated on, right? So then when you come back around to it, you can say, oh, how, you know, we're on tick 37, and it says the last update was on tick 25. Well, I know there's been that many ticks in between when I last updated this guy, so I can give him that much movement radius or something, right? You know? But I don't know. James, why does it not suffice to use the total area of all overlapped regions and just refuse to exceed a limit? It does work. It's just A, you get slower as that limit gets bigger, and B, it has to have a limit. And then you have kind of bad behavior when you get enough people together that you're outside the limit, right? But again, you know, that something like that is probably what we will do, because I don't know if there's a clean solution to this. I also don't know if it's really that we're like, it just happened to be something we were talking about right now, so I thought I'd rediagram it just so people knew what I was talking about. It's not something we really have to solve right now either. We can just sort of try it out a little bit and see. We don't really know what we need out of this for features. It's kind of just a speculative, like, hey, it would be cool if you could have things going on the map that were happening in places you weren't. And but I just don't know how feasible that is, and maybe it's a stupid idea. We don't have to do this. The game does not require us to do this in any way, right? It just seemed like something that we were close to being able to do cleanly, so it was worth thinking about doing. Because since we do have the sim region stuff, we can render little peepholes of the world without doing. I'm sorry, update little peepholes of the world. So, you know. Anyway, food for thought, something to think about. I'm going to go ahead and, close this down here. All right, thank you everyone for joining me for another episode of Handmade Hero. It's been a pleasure coding with you as always. If you would like to follow along with the series at home, you can always go to handmadehero.org and pre-order the game. It comes with all the source code, so you can play around with it at home and learn from it and so on. We also have a forum site you can go to if you want to ask questions about what's going on. We also have a Patreon page you can go to if you want to support the video series, a schedule bot, which tells you when we're going to be live if you want to catch these episodes live, and also an episode guide you can go to if you would like to catch up on past broadcasts. That's about it for today. I will be back here for the last stream of the week tomorrow. Same time, same place. Until then, have fun programming, and I will see you guys on the internet. Take it easy, everyone.